All right, we're in section 10.1 where we're going to apply the counting principle and permutations. So, uh, expanding on uh, items of probability and statistics, a little bit of this is a review from other classes. Some of it we're putting some new wrinkles in. Uh, First and foremost, we're going to talk about the fundamental counting principle. The fundamental counting principle basically says, or it's a way of determining how many ways you can occur something depending on how many options you have. So in this case here, you are simply taking, okay, how many options do you have for this category, multiply how many options for this category, multiply for many options for this category, and so on and so forth, till you get how many possible choices you have. So if we were to implement the counting principle to this problem, it says you are buying a pizza, you have a choice of 3 crusts, 4 cheeses, 5 meat toppings, and 8 vegetable toppings. They want to know how many different pizzas with 1 crust, 1 cheese, 1 meat, and 1 vegetable can you choose from. So how many crusts do we have? We have 3, so we got 3 times it by the number of cheeses, which is 4, times by the number of meat toppings, which is 5, times it by the number of vegetable toppings, which is 8. So then you multiply all 4 values together and you get an answer of 480 different pizza outcomes, all right, or different pizzas that you can make. Okay, so using the counting principle again, we can figure out some other items. It says in this problem that a town has telephone numbers that begin with 329. They want to know how many how many 4 digits phone numbers are possible. So we have 329, which are the first 3 numbers in the telephone, and you got your 4 numbers here. So the first um, or the first opportunity that we get to choose is the 4th digit. So that can be either be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 possible choices. All right. There's also 10 possible choices for the 5th number, 10 possible choices for the 6th number, and 10 possible choices for the 7th number. So we just simply multiply those 4 numbers together and we get 10,000 different numbers. Now the second option here says if numbers cannot repeat, so you can't have 2 9s or 2 7s or 3 6s or whatever. So basically what they're saying is you have 10 choices for the first one, and whatever choice you picked, that one gets eliminated. So now you only have 9 choices for the second one, and then it means you only have 8 choices for the third and 7 for the fourth, and then you multiply those 4 numbers together, so it's 10 times 8 times 7, which gets you a result of 5,040 different numbers. So it's definitely predicated on what uh, what they're asking you is, can it be repeats, can there not be repeats? So here it says how many different 7-digit numbers are possible if all digits can be repeated. So we have 7 possible numbers, and since there can be repeats, we have the opportunity to have 10 in all 7 spots. So, you know, so there's the opportunity to have 10 possible outcomes, multiply all of them together, you would get 10 million different phone numbers. Okay. Over here it says you have 8 teams are competing in a playoff game. They want to know how many different ways can the teams finish the competition. So you have 8 teams. That means that um, you have the potential to be either eighth place, seventh place, sixth place, fifth place, fourth, third, second, or first. All right, to determine how many possible outcomes. Well, since we have an order here, means you have the opportunity to be any one of these places. So you just multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And the results are there are 40,320 different ways that the teams can finish. Because order is important here. In this one here, it says, in how many different ways can three teams finish first, second, and third? Well, you can either be first, you can either be second, or you can be third. Multiply them all together, so that means there are 6 different ways that three teams can finish first, second, and third. Here it says how many different ways can the teams finish if there are 6 teams competing in the playoffs. So you could be 6, you could be 5th, you could be 4th, you can be 3rd, you can be 2nd, you can be 1st. Again, multiply all those together and you get 720 different ways you can finish. And this is kind of a nice little segue that deals with permutations. All right, these are examples of all types of permutation problems because order was important in the arrangement because when we talked about teams finishing, all right, they had an order. All right, someone had to finish first, someone had to finish second, someone had to finish third. All right, when order is not important, you deal with combinations, which we're going to talk about that in future lessons. But since order is important, we have to utilize that. All right. Another thing that we have to keep in mind when we're looking at permutations is we have to be able to understand the term factorial. Okay, so factorial is you have a number and that number is followed by an exclamation point. All that means is you are going to take consecutive integers and multiply them together until you hit the number that is before the exclamation point. So if you had 6 factorial, this is just going to equal 1 times 2 times 3 times 4 times 5 times 6. I stop at 6 because that's what it is there. And then you just say 1 times 2 times 3 times 4 times 5 times 6. And that's where the result of 720 comes from. Okay? But when you're dealing with permutations, not every object is going to be arranged in an equal number of positions. So sometimes you're going to have n objects and arrange them in r different ways, okay? So 2 things have to keep in mind. N must be greater than or equal to r. That must be true. And this is the formula that allows us to look at these different problems. So another thing you want to keep in mind when it comes to factorial, you have 0 factorial, that equals 1, okay? It means the same as like 1 factorial. 1 factorial also equals 1, but keep that in mind when you are solving these different problems. So utilizing permutation formula, it says you have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. And how many orders can you complete 4 assignments um, for the assignment? So permutation where you have 6 homework assignments and there's 4 ways that you can arrange them. So this is going to equal 6 factorial on the top over 6 minus 4 factorial. Well, 6 minus 4 factorial is 6. So what I usually do is I expand it. I go 1 times 2 times 3 times 4 times 5 times 6 over 6 minus 4 is 2, so it's 1 times 2. All right. These get canceled out to be 1, so all I have to do is multiply 3 times 4 times 5 times 6, which gets us 360 possible outcomes. Here we have it says you are left a list of 9 chores to complete. In how many orders can you complete 5 of the chores? So permutation where you have 9 arrangements and 9 objects, I'm sorry. nine objects and you're arranging them five different ways. So it's going to be 9 factorial here, and it's going to be divided by 9 minus 5 factorial, which in this case, sometimes these expansions can be a little bit long. So if you realize that this is 9 minus 5 is 4 factorial, so you can realize that both 1 times 2 times 3 times 4 get canceled in both the numerator and in the denominator. So all you really have to do is write, especially on the top, 5 times 6 times 7 times 8 times 9. Multiply those out, and you get 15,120 different ways. Okay. One of the other things that talk about permutation is permutation with a repetition. All right, it says the number of distinguishable permutations of number n objects where one object is repeated s1 times, another is repeated s2 times, and so on and so forth is, so it's n factorial, which would how many objects there are in the particular problem, and then the repeats, if you have one repeat, it's how many times does it get repeated, so that gets factorial. Another times it gets repeated here, it's 2 factorial, and so on and so forth. And I'll show you what that looks like. So here they want to know the number of distinguishable permutations of the numbers in each of the following. So they want you to look at even. Even has 1, 2, 3, 4 letters, of which E is repeated 2 times. So using that formula up there, we have 4 letters, so it's going to be 4 factorial on the top, and it's going to be divided by, well, I have 1 repeat, which was E, and you saw it 2 times, so it's going to be 2 factorial. So it's going to equal 1 times 2 times 3 times 4 over 1 times 2, cancel, cancel. I get 12 possible outcomes, possible distinguishable permutations. For B, I got California. California has uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters, but A, because it's a repeat here and a repeat here, and I, which is a repeat here, here, and that looks like it's about it. They're both repeated twice. So in this case here, I'm going to have 10 factorial on the top, and it's going to be divided by, so with the a's twice, it's going to be 2 factorial times it by the i's, which is also another 2 factorial. So this is going to equal 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 divided by 1 times 2 times by 1 times 2. Cancel, cancel. So on the top, you have 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 gets you what, one, so 1814400 comma, so 1,814,400 divided by 1 times 2, which is 2, divide that by 2, so now I get a total of 907,200 distinguishable permutations. So if we look at these examples here, tomorrow, the word tomorrow is 1, 2, 3, 4, 5, 6, 7, 8, 8 letters. So it's got 8 factorial on the top. What repeats do I have? Looks like I have a repeat O here that happens 3 times. So that's where 3 factorial goes on the bottom here. Times it by, I have 2 here for R, so that's going to be times by 2 factorial, so I get 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 over 1 times 2 times 3 times 1 times 2, cancel, cancel, cancel. I get 4 times 5 times 6 times 7 times 8, and then divide that by, what, 2? When I divide all that by 2, I get 3,360. I look over to my right. Yesterday is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 factorial on the top. It looks like E is repeated twice, so 2 factorial here. And I believe anything else, y is repeated twice. So that's where I get there. So I get 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 over 1 times 2 times 1 times 2. Cancel, cancel. I got 3 times 4 times 5 times 6 times 7 times 8 times 9. And divide that by 2. I get, let me try this again. So, yeah, it should be 3 times 4 times 5 times 6 times 7 times 8 times 9. I get the 181,440. Divide that by 2. I get 90,720. Okay, so that is the number of distinguishable permutations for those ones. And that is how we apply the counting principle and permutations. Hope this helps. Till next time.